So let's continue with the chapter oscillations. Okay. Last time we have studied that if there is a spring mass system, so last time we have studied that if there is a spring mass system, that is a mass m attached with some kind of spring, and then if you pull it and you leave it, there will be oscillations, right? That is, this will go back and forth, right? So that was an example of simple harmonic motion because it follows the required conditions, right? Once again, the required conditions are this or this. Okay, that the net force on the body is equal to minus k delta x and acceleration is proportional to minus delta x, that is negative of displacement, right? What is this k called? Do you remember? If we are talking about SHM, what is this k called? What is k called? Yes, very good. Yes, force constant. Okay, don't call it spring constant. Remember, sometimes it will be spring constant, but generally in SHM, the name that is used always or can be used always is that K is force constant. Okay, fine. Now we are going to talk about how the particle moves, and we will relate it with the mass, the equation that we have derived earlier. We have seen that equation for SHM can be written as x equal to a sine omega t plus phi 0. Here a, omega and phi 0, they are some constants. Okay, they are some constants. We are going to give meaning to these constants. Okay, we are going to give meaning to all of these constants, right? So that's what we are going to talk about. Now, before we proceed to that, we will have to look at sine. You see, we have different values for sine as we change this whole angle. Remember, this whole bracket is the angle. So, listen to this carefully. If we take this angle to be 0, that is when this angle is 0, that time we get sine 0, that is 0. So, x would be 0. Right? So, what we are saying is that putting this angle as 0 gives you x equal to 0. Right? But you know that if you put this angle to be something like pi by 2, 90 degree, that would mean the value of sine 90 over here at this point is 1. Right? Okay? So in that case, if I put the value of this sine as 1, okay, so then I'll get x equal to plus a. But if I go to the other point here, where the value of this angle would be minus 90 degrees or maybe to 70 degrees, right? So for such a case, we are going to get the value of sine as minus 1. Clear so far? Right? So when this is minus 1, when this whole value of sine is minus 1, then x will be minus a. Right? So all of this maths that we are seeing here can be realized or can be seen for SHM also. Let's draw a diagram here. This is the mean position which we will take as origin, right? Keeping it simple. Here is the end point on the right side and here is the end point on the left. Let's say right side is positive, so this is x equal to plus a and this is x equal to minus, right? So now if some particle will oscillate like this and then back and like this and then back. Did you understand what oscillation is in this form? Okay, so what we are seeing is that the maximum value of x possible is plus a. The maximum value of x possible is plus a, right? Okay, so that we will get when the value of sine, this whole thing is 1. So x equal to a into 1. Is that fine? Right? So that is when particle is at E. E, that is what? X equal to plus a. Do you realize that we should have x equal to a, which is equal to a sine omega t plus phi 0, right? So that would give us that would give us sine omega t plus phi 0 is equal to 1, right? So basically whenever this value becomes 1, where is the particle? The particle is at extreme position. The particle is at extreme position, that is on the positive extreme position, that is at x equal to plus a. Did you understand what we have indicated here? Yes, Mahavir, you could say that. Okay, but let's think of the other point. Let's think of the other point. Okay, so that is when particle is at E dash. E dash, that is when x will be equal to minus a. Then by doing similar calculations, you realize that we are going to get omega t plus phi 0 equal to minus 1. Okay or not okay? So now hopefully you have realized that this a that we are using in this equation, if you write a here, I repeat, if you write a here, what that would mean is that the particle will move between plus a and minus a. Correct? If you write a in this equation, the particle will move between plus a and minus a. Clear? So this a or this a here, what is this a called? Do you remember what's that a? A for? That A is for? Okay, we had a power outage. Let's continue now. So we were talking about what happens when these values change, right? The particle goes to plus a when this happens, that this value is 1, and goes to minus a when the value is minus a. Okay, so like I was saying that this a here, this constant here a represents the amplitude of motion. Right? Okay, so instead of this, suppose for example we have an equation like this. Okay, something of this type. Then this 2 would be the amplitude of simple harmonic motion. Okay, again amplitude means the maximum displacement from mean position. This is what is called amplitude, right? Okay, so this number that we get here in this pattern of equation, this is the amplitude of simple harmonic motion, right? So one constant clear, everybody. This a is clear, a for amplitude of this SHM, right? We will now be going over to the next constant. Okay, the next constant that we are going to explore is phi 0. Okay, we will understand what is meaning of phi 0. Okay, so I'll just clean this up a little bit here so we can draw a new diagram which you can easily see. Okay. So let's say these are the mean positions and the extreme position. Now, to understand what is phi 0, let's start with this equation and do a little bit of mathematics. Okay? At time t equal to 0, of course t stands for time in this equation, so if we put time t as 0, right? Okay, so this would mean initial case, isn't it? Generally whenever we take time t is 0, we call it the initial case, correct? So if I put time t equal to 0, we get x equal to a sine phi 0. Is it okay? We get x equal to a sine phi 0, right? So now, why do we call it phi 0? Why do we have this type of symbol, right? And what does this mean? So let me tell you the name first of all, and then we'll go to the diagram to understand what it means. Phi 0 is called phase, initial phase. Okay, phi 0 is called initial phase, or sometimes we call it phase constant. But frankly, the first word is easy to understand, right? It is called initial phase, right? Phi 0 is called initial phase, right? So what does this phi 0 indicate on this diagram, or what happens because of phi 0 in motion? Right, let's see. Suppose, okay, I'll take a few examples that will help you understand how phi 0 affects motion. Okay, so if we will take phi 0 is 0, suppose, okay, this is to understand what's the role of phi 0, what does phi 0 do to motion, right? So if phi 0 is 0, then that would mean at t equal to 0, x equal to a sine 0, that is equal to 0. Did you understand this line? Comes from here. Clear or not clear? Okay? Now, what would that indicate? This would indicate that at starting, initially at time t equal to 0, what is the position of the particle? It is at origin. The position of the particle is at origin, that is at the mean position. Did you understand what I am saying? Right? So, if you know that phi 0 is 0, that would mean we can say that particle was at mean position at t equal to 0, right, and starts SHM from there. Is this clear? Is this clear or not clear? It would start from here, right? When we first saw the particle at time t equal to 0, the particle was here, right? Okay, so why the word initial phase? You see, phase is something that indicates passage of time. If you think about it, don't we say in this phase of your life, or in this phase of this match, or this phase of whatever time we are talking about. So phase means a particular part within some time, right? Okay, or for some particular process. So here when we say initial phase, so it indicates where it was at starting point. Okay, that's why the word initial, right? So particle would be at mean position at t equal to 0. That would mean phi 0 is 0. Let's take one more example. Suppose, okay, this is another example. So this was one example, this is another example. To understand what is the role of phi 0. Suppose phi 0 was minus pi by 2, let's say. Suppose phi 0 was minus pi by 2. Minus pi by 2, that is minus 90 degrees. Let's see what would happen. Let's use this again. At t equal to 0, we would have x equal to a sine minus pi by 2. Okay? So this is going to be a into sine minus 90 degree, or sine minus pi by 2 is minus 1. Clear? Right? Okay? Sine minus pi by 2 or sine minus 90 degrees is minus 1. So this would mean this is equal to minus. What does that tell you? At t equal to 0, the particle was at which point? Minus x. So where? At e or e dash? Come on. At t equal to 0, particle was at e or e dash? Yes, e dash. Very good. So once again, hopefully you realize that this initial phase phi 0 is what decides where does the particle start its SHM from, right? So what this would mean is that the particle started SHM from the extremity, right? The extreme point. But with on which side? From the negative side. Okay, from the negative or the left end point. Okay, did you understand this sentence? Right? Okay, so basically particles started SHM from here. So both these examples hopefully make you realize what is the role of this phi 0. Okay, I am not giving more examples. Of course you can think of more examples, like for example, what would happen if you put phi 0 equal to pi by 4, let's say. Where would it start? Can you tell me if phi 0 is pi by 4? From which point the SHM would be starting? Can you tell me that? If phi 0 is pi by 4, where would it start from? Where would SHM start from? Can you give me the value of x exactly? If phi 0 is pi by 4, can you tell me at which point will it start from initially? It will not start at e or e dash. Okay, those who have given that answer, please correct your answer. Think about it again. Yes, Raj, well done. Divya, correct. Pi by 4 is how many degrees? Everyone must learn to convert between radian and degrees. Everyone, pi by 4, how many degrees? 45 degrees. Very good. Use that. Come on. Use what we have got here. Over here, come on. Where would it start? X value. Come on, Ria, I want value of x. No, your answer is not right. No. So this would be at x equal to a by root 2. Is that clear? X equal to a by root 2 will come on the positive side. Somewhere over here. Okay, this is where you will get x equal to a by root 2. So x equal to a by root 2 falls between m and e. Okay, somewhere between m and e. Understood? X is not 1 by root 2, x is a by root 2. Anybody who is struggling here, you have the following thing to do at home today. Revise all the trigonometric values that we know, okay? Right? And also go through some of the basic ideas about trigonometry, okay? Because this chapter will use a lot of trigonometry. Okay. Fine. So in short, if I just want to say what's the role of phi 0, I can say phi 0 tells us where the particle is at t equal to 0. Isn't it? Do you agree with this sentence? It decides the initial position of the particle, right? It decides the initial position of the particle. Okay? Now, let's take a practical aspect of the same thing. Okay, let's think about it as if we are doing some experiment. Let's see. Suppose once again that there is a wall here and there is a spring. Let's say this is the natural length of the spring. Okay, what I've drawn here. Now we pull the spring out. Okay, so the spring gets a little bit extended. Okay, and let's say it is still in my hand. Okay, I'm still holding this in my hand, right? Then if I let it go, if I would let it go from here, right? What will this initial position be? Will it be end point? Will it be midpoint? Will it be anywhere in between? What do you think? If I let it go from here, I release it from here, what will be the speed? That will help you decide. If you release something, speed is 0. So what will be this point? Will it be the midpoint? Will it be the extreme point? What do you think? Yes, it will be the end point. Correct. It will be the end point or the extreme point on the right side. Well done. So this point will actually be corresponding to E, right here. Okay? Right? So if I will drag it like this and then I release it, it will do SHM. But in this practical case, can you tell me what will be the value of this constant phi 0? Can you tell me what will be the value of this constant phi 0 if I write its equation as x equal to a sine omega t plus phi 0? Then what will be phi 0? What will be phi 0? Okay, we have got a couple of answers. Right, very good. We want to find the value of phi 0. Okay, we don't want to find amplitude or anything. Well, see, it starts from here. It starts at extreme position. So do you realize that at t equal to 0 means initially x is equal to a? Is this clear first of all? Yes or no? At t equal to 0, x is equal to a. Yes or no? Why x is equal to a? Because here v is 0. At which point? At which point is the speed of particle 0 while doing SHM? Think about it. Okay, we talked about it last time. I told you whatever was on the board at that time, very important. This is one of those things. At which point is the speed 0? At amplitude position or at extreme position the speed is 0. Clear? So x is equal to plus a because it's on the right side of this equilibrium. Here there will be equilibrium or mean position. So if I put x equal to a and t equal to 0 in this equation, what will I get? A equal to a sine 0 plus phi 0. So I am sure you understood that 1 is equal to sine phi 0. Clear or not clear? Clear or not clear? X equal to a, and here we have a cancelled, you get 1. Okay, so this would mean that we should have phi 0 equal to pi by 2. This is one of the many possible answers, but this is good enough. Okay, math students will realize that this is not the only answer possible, but others, don't worry about it. Phi 0 equal to pi by 2 is a perfectly valid answer. We don't have to worry too much about the other answers. Okay, so that is what phi 0 is, right? So this is how, in a physical situation, we can decide what is the value of phi 0. Let's take a slightly different example this time. Instead of stretching it, let's say we compress it, let's say I push it. Okay, so the spring will become like this, and then I let it go, then I will let it go. Then here initially once again the speed is 0. This time this is at which point? This time this will be at which point? The starting will be at which point? Yes. Okay. People understand the question properly. Right now I have only asked the starting is at which point. Then the answer is starting is at E dash, that is extreme point on the left side. Clear? Extreme point on the left side. So here for this point, if we will repeat the calculation, do you realize this time we'll have x equal to minus a? Yes or no? Yes or no? We'll have x equal to minus a. Yes or no? Okay, fine. Then obviously if you do the same kind of maths here, you will get sine phi 0 equal to minus 1. So that would mean phi 0 is minus pi by 2 or minus 90 degrees. You can write either, but we generally prefer this. Okay, both are correct though. Well, so that's what we get for initial phase. So once again, by looking at how the motion is starting, you can decide phi 0 and vice versa. That is, phi 0 is what tells us where the particle is at t equal to 0. Is it at the extreme point on left side? Is it at extreme point on right side? Is it somewhere in between? Is it at mean position? Whatever it is, that information comes from phi 0. Clear? Okay, fine. Let's solve a very basic question using whatever we have learned so far. It's that suppose the distance between extreme positions in SHL is 10 centimeter. At t equal to 0, particle is found at 5 centimeter from origin on the positive side. Find amplitude and initial phase. Okay, you will not get more than 1 minute to solve this question. Okay, time has started. Hurry up. Draw the diagram first of all. Try to indicate the given details in the diagram. Mahavir, where you are releasing that block, speed is 0. Where you are releasing that block, speed is 0. Whenever something is released, speed will be 0. Okay, so that time, if speed is 0, that would mean the particle is at extreme position. That's what we have learned yesterday. Okay, it has not much to do with compressing or stretching the spring. Hurry up everyone, so very simple question. Very little calculation to do. Unit લખો, unit વગર તો શું કામનું? Only amplitude A, but how much? You have to find amplitude. Okay, generally people are giving right answers. Okay, I am going to put the diagram on the board that will make it absolutely clear. Suppose here is origin, right, and this is E and E dash. So it is given that distance between two extreme positions is 10 centimeter. Clear? So that would mean 2A is equal to 10 centimeter or A is equal to 5 centimeter. Absolutely clear? 2A equal to 10 centimeter or A is equal to 5 centimeter. Okay? Right. And now where does it start from? At 5 centimeter on the positive side. Okay. Here, isn't it? So starts at E, means positive extremity. Okay, starts at the positive extreme endpoint, right? So here this would clearly mean that at t equal to 0 you have x equal to 5 centimeter, which is same as A. That would clearly mean 5 is 5 by 2, just like we have done. So this way you can do it very easily if you have solved a couple of cases. Okay, hopefully now you will retain this knowledge. Okay, I'm going to erase everything on the board now. Okay, now we still have third constant to explore. We are done with A, we are done with phi 0. What about omega? Right? That's what we are going to talk about now. Well, see, if you write the equation as x equal to A sin omega t plus phi 0. Now, like I was explaining earlier, that if you think of the unit circle or you think of sine values and you start over here at 0 degree, you go around, you come back to this, the angle becomes 360 degree. But like I said earlier, that with a gap of 2 pi, the values of sine and cos, they all repeat. Correct? That is, if you go and increase the angle by 360 degree or increase the angle by 2 pi, then the value will repeat. So what I mean to say is something like this once again, that sine 10 degree will be same as sine 370 degree. Did you understand this, everybody? Yes or no? Sine 10 degree is same as sine 370 degree. Okay, so just like this, I could actually take any angle, whatever angle I take, and I can add 2 pi to it, and the value will always be the same. Did you understand this equation? Math students, of course, I am not asking you. If you don't understand this, you wouldn't be here. Okay, is it clear that adding 2 pi will not make any difference to the value, right? Okay, so this is what we are going to use to understand what is omega. Right? This is what we are going to use. Let's see. So if you have got an equation like this, then do you realize that this same value we will get even if I would write this as this. Okay, that is adding 2 pi. Adding 2 pi to it should make no difference. Correct or not correct? Correct or not correct? Is that clear? Adding 2 pi makes no difference. Okay. Now let's play a little bit with this here. If I would take omega common from here, I know it's not common, but I will take it forcibly. Okay, so that's like dividing outside and multiplying inside. If you don't understand this step, try to go backwards from here. Multiply omega inside, you will understand. Is this clear or not clear? Okay. So, what this means is the position of particle at time t equal to t is this. Okay, that's what this equation is for. Position or x coordinate of the particle at time t equal to t. So do you realize that this is also equal to, if you try to understand here, what's at the place of t? What's at the place of t here? So I can say that this position is same as position of particle at t equal to, or at time, which time t plus 2 pi by omega. Did you understand this? Whether you are doing it at time t or you are doing it at t plus 2 pi by omega, the value of x is equal. Yes or no? Yes or no? Is that clear? Okay. So what does this tell us? It's saying that wherever the particle was at this time, it will come back to the same point, to the same position after how much more time? 2 pi by omega, isn't it? Right? So for example, you could say that suppose the particle was somewhere here at 1 second. Then the particle is going to repeat everything once again after how much time? After 2 pi by omega. That is, it will come to the same point, it will repeat all the motion after a time 2 pi by omega. Is that clear? Okay, so seems like you all can listen to what I am saying. So I see the video has paused. So what we'll do is we will start from this point. Okay, I'll start explaining from this last point. Okay, I will start explaining from the last point the next time. Please note down whatever we have on the board. Okay, please note down whatever we have on board. I have not written anything after those two sentences, right? Okay, we will continue from here. I will explain that again, don't worry. Let's end the class. Goodbye everyone.